Our next topic are X-linked traits. These are traits that are carried on the X chromosomes and can be passed from parents to children. So for example, Becker's muscular dystrophy is a recessive disease. Most of these are going to be recessive diseases, typically found in males that cause muscle atrophy. It's an X-linked trait, meaning it's going to be carried on an X chromosome. So again, this is going to be a little bit different than what we've been doing. Females have XX genotype. Males have an XY genotype. Let's go ahead and fill all of these in. Now, heterozygous organisms can be carriers. Because this is a recessive trait, the dominant genes will not carry a trait, but the recessive traits do carry a trait. And I picked the letter B just because it's easy to show the difference between large and small, uppercase and lowercase letters. Now, using this, we can fill these in. A female carrier will have one large letter, one small. A male without, so male no trait, will have a small letter. Now, the Y doesn't carry anything. The Y will donate a little bit of genetic information, but it's not going to carry anything like this. It's an X-linked, so it's being carried on the X chromosome. So a male with this trait would have a little b, and this one is actually a capital because it's without. Sorry. Female with this trait is going to have a little letter on each, and a normal female means no trait, big letter on each. This you're doing the reverse. If there's a big letter, then it means no trait, XY, it's a male. So I'm going to say male without, this is XLA. Same thing all the way down here. Now let's set up our first Punnett square. I'm going to give you one example. We have a woman who is a carrier. Let's set up our square first. A woman who is a carrier, so you have two X's. Put that over here for you. Here's our female. She's a carrier, so she has mixed, big B, little b. Our male does not have this disorder. We're going to fill in our Punnett square. X goes first. Big letters go first. Alright, it says how many can be expected? Using this key from up here, we can say that we have one female without, one female carrier, one male without, one male with. So 50%, let's just fill this in here, 50% will have XLA from here, because we have one carrier, one that's carrying this trait. You have two sons, half of them will have this trait. So the question's actually asking, if you have 4 sons, how many will have XLA? We have 2 here, one of those 2 has it, so that's a 50% chance. Same as if you doubled it if there were 4 sons.